Great. Thank you so much for letting me jump in for Tony. So I'm here on behalf of Tony Brazel, who is in very good health, but the trip from Phoenix to Sydney is a 17-hour flight, and it would just been a little bit too strenuous for him. So I have the great honor of presenting kind of our research, but he is the main driver of this research, and it's an analysis we've been working on for several years now, and I will be talking about networks in Arizona that can be used for urban analysis. So the motivation of this study comes really from a paper from 2013 authored by Mueller et al. And the group around Mueller did an analysis of sensors in cities and looked at their purpose for urban analyses. And there's a list of networks they identified back then in 2013, and you can see that Arizona is one of the longest record networks on this list. So this is from 2013, and this says 29 years, but you have to add roughly 10 years to this number. So the AZMET network in Arizona has been in operation for about 39 years now. And it's very impressive, has several, I'll show you a map shortly of where the stations are located. So it's a pretty useful network for all of us in Arizona to do urban research. It's been running since 1986. It's a part of the extension by Meteorological program that's at our competitor university, University of Arizona in Tucson. The network, as I said, started in 1986, and it was actually not installed for urban research purposes. It was actually installed for agricultural purposes, but it has been the longest continuous recording among all these networks, as Mueller identified, and it has a very high quality. So each AZMET station is usually visited by a technician every 3 months, and then they set up laboratory standard sensors next to the stations to compare to current measurements. Then they also calibrate the wind sensors and the solar sensors once a year, and the temperature and humidity sensors are also calibrated every 2 years. So it's a really, really high quality. There's a picture here on the slide. Air temperature is at 3 meters height. And again, the original purpose of this network was for turf management. And then the secondary purpose for us at ASU and other universities in Arizona is to use it for urban research. So there are 28 stations in this network. They are solar powered. They are on a 10-foot tower for the wind speed. And the measurements are stored on a data logger every hour. And then at 1 o'clock or so, during the night, all the measurements are being pushed to the server, and then you can access a website to download the data. Parts of the data that are being collected in these network, and there's a map right here. It's a little bit tiny. Can I use the pointer? So Phoenix is right in the center here. This is Phoenix and Canto. It's a park in the metro area, and then this is Arizona. There's Flagstaff right here, and the urban core is probably this area right here, and then you have another urban core around Tucson, and then you have some stations that are more in an urban setting. So these stations, they collect temperature data, air temperature. They also collect soil data, which is really useful if you would like to run an ambient model, for example, because you need soil temperature and moisture for that. Collects water vapor pressure deficit, solar radiation, wind speed direction, and then also precipitation. There's also a lot of variables that are computed from what's being measured. So the network computes degree days, chill hours, dew point, and then what's called the reference crop evapotranspiration. And that tracks the amount of water that can potentially be lost from the basin and returned to the atmosphere. So in the southern part of the state, and then Also in the metro area, if you have a large body of water, such as a lake or canal, or even an uncovered swimming pool, those can lose over 2,000 millimeters of water evaporation every year. And then in comparison, if you look at the normal rainfall during that same period, that's, well, roughly about 200 or 250 millimeters per year. So that's, that there's a comparison right there. AZMet is the only group that has been continuously monitoring this reference crop evapotranspiration. And the growers in this region, farmers, they can use this to apply the necessary amount of water which meet the plant's demand based on the potential evaporation. So it's really useful for farmers in this region. Also, cotton, for example, remains a major segment of farming for Arizona agriculture and is a really important part of our economy. And the AZMet network, every Monday between March and August, they generate cotton advisories for various cotton production regions across the state. So it's and also, although it's not really a traditional agriculture, we do have a lot of turf because we do have a lot of golf courses. So there are 330 golf courses in Arizona. Could be a couple more. And AZMet has worked really closely with the turf industry in an effort to conserve water. And so these stations in the Phoenix area that are located on golf courses, those measurements can really help the golf courses manage their water demand and water consumption. So these are some of the special reports generated by the network. So that's the original purpose of this network. So now the question we were most interested in is, since this is such a long history of measurements, do we actually see an urban effect in these networks? Because usually you have your weather station located at the airport, which is not necessarily representative of an urban area. So now these stations are spread across the whole area. And can we see an urban effect in the temperature, the wind? So that's what I'm going to focus on in this presentation, and also the cooling rates that we can derive from the temperature readings at these stations. We also did some research on the impact on the solar radiation and vapor pressure deficit and all of that. I'm not going to go into detail about that, but Tony is going to watch this presentation. That's what he told me. So if you have any questions afterwards that I cannot answer, or any other questions, just feel free to contact him, or he will watch the presentation and then contact you. So in terms of the methodology, what we did, because we are treating this as an urban network, we are categorizing all these stations into local climate zones. I mean, that was not the original placement intent. The AZMet creators did not have a list of local climate zones and said, okay, we want to have a station in this zone and in that zone. But we went ahead and looked at all the stations and aerial photographs, and then tried to assign a local climate zone to each of those stations. And then we calculated cooling rates similar to a paper by Winston Chow and Bob Smoma from 2011. And those cooling rates are essentially the difference in air temperature between two time steps throughout the whole night. And then we calculated the average cooling rate for each of the stations, and then also the maximum cooling rate. And we did this for a representative week in June of 2015. And then I'm going to show you some results for air temperature and wind speed as part of this network. So here's a map of the network again, and you can see a local climate zone classification map from 2018, which we did as part of another effort. And we were trying to assign all these different stations a local climate zone. And we included another network in this whole analysis. It's called PRISM. It's not as old as AZMet, but there are some stations here from the PRISM network. They are in the blue color right here. And as you can see from the top, these are the urban stations. So we have Sky Harbor, which is mostly paved and a little bit of soil. And then we have 3 stations here that are mid-rise and low-rise open local climate zone. And same here, this is a open low-rise with different vegetation. And then these are the stations we considered rural. Queen Creek, Buckeye, if you're familiar with the Phoenix area, those are really in the suburbs and outskirts. And those are local climate zones D and F. D is low plants, by the way. So these are some aerial photos of these stations. We drew a circle with the radius around the station, and then we looked at the land cover and assigned it whatever we thought came closest to the local climate zone that we were interested in. And then here, this is the other network I mentioned. It's called PRISM, and these are the PRISM sites. And you see some of these are really very urban. This is the open low-rise neighborhood I mentioned, local climate zone 6. And then some of these are really, really rural. They have a lot of agriculture here. So this is D and F. D is low plants, and then F and E. F is bare. Here are some results for air temperature, and we see a very traditional urban heat island story here. This is the maximum minimum temperature for this week of June. And if you look at the bars up there, does it still work? Yeah. The tall bars, these are the maximum, the small bars are the minimum. The minimum temperatures have a strong urban signal. So the airport, that's EF, the one to the left, that has the highest bar, and then the more agricultural sites to the right have the lower bars, and then the chart to the bottom left is the actual difference in temperature, and that's the same story. So if you have your urban sites, they exhibit a much stronger temperature difference compared to the rural sites. And here are the cooling rates. That's the second column from the right, and they are arranged by size. So the lowest cooling rate is the top row, and that's Sky Harbor Airport, and then the strongest cooling rate is the last row, and those are the agricultural sites. So I have two more sites, and then I'm happy to take questions. This is the vapor pressure deficit as measured at these sites, and there's a very strong urban signal here too. So the vapor pressure deficit is higher at the urban sites with the less irrigated exposed surface area, and then they are lower at the rural sites. And then this is the last story here. This is the wind speed. And I apologize, there's a lot going on and it's all black, but the main story is that the wind at the urban stations is much lower than the wind at the rural stations. And we found a small anomaly here. There's a little break in the wind measurements, and we found that this is because they switched the sensor and didn't tell anyone. So yeah, in summary, the AZMet data network is really, really useful for urban research. There's a bunch of references, including research from our chair, Meteorological here, that used the network to force urban climate models or to validate models. It has a bunch of applications. The benefits are it's really, really high quality. Danger is that sometimes they don't really publish the metadata, and they might swap a sensor on you if you don't realize. But overall, it's a really, really great resource for this area. And with that, I would like to thank you. This is a picture of Tony and myself at a hockey game, and I would be happy to take questions.
We have time for 2 quick questions or 1 longer question. Oh, okay.
Yeah. Thank you for this, Ariane. How did you advocate for maintaining this whole weather network? Because in the UK, for example, at a certain point, funding plummeted, and so they just cut it all off. How do you advocate for that?
I believe the University of Arizona is a land grant university, and as part of this agriculture extension arrangement, they have funding allocated to run these networks. So hopefully they're not going to run out of funding, but I think it's a fairly stable funding stream, and hopefully this network will be around for many, many years to come. The only danger is that at some of these stations, as they, say the station that's at a golf course, maybe the golf course gets converted to something else, and then they decide, well, it's not an agricultural station anymore. It's maybe not a location they would prioritize, and they might remove the station. So then that would be bad for the urban folks. But generally, this is a well-funded network that's going to exist for some time in the future.
Please join me once again in thanking our president. we're gonna move on now. We're gonna go back to